Example 10. Solve the equation over the interval 0 to 2 pi and also for all solutions. Cosine of 2 times x is equal to the sine of x. All right, with this particular equation, you can see that the argument of cosine is not exactly x. It's 2 times x. So this is a double angle. When you have an argument that is not exactly x in this case, you have two options. Okay, either you can do the u substitution like we did in example 9, or you can use a known trigonometric identity to make a substitution. Okay, so with the last question, we did not do a substitution of a known identity because we had a half angle, and those formulas are really complicated. But the double angle formulas are not nearly as bad. Okay, so this is double angle for cosine. I am going to jot down those formulas, the double angle formulas for cosine, okay, so that you don't have to dig back to get them. We know that the cosine of 2 times a is equal to cosine squared a minus sine squared a. And then there were 3 of them, so cosine of 2a is also 1 minus 2 times the sine squared of a. And then the last one, cosine of 2 times a is equal to 2 cosine squared of a minus 1. Okay, these look a lot better than the half angle formulas. Okay, so we are going to try to do a trigonometric substitution here with one of these identities. Okay, we will replace the left hand side. Okay, this is cosine of 2 times a. A is the same thing as x. We just need to figure out which of the 3 formulas will be in our best interest. Okay, the first equation here involves both cosine and sine. I'm not going to go that route because I'm still going to end up with 2 trigonometric functions in my equation, and I'd like to avoid that. Okay, I think the second one is the best way to go because it has a sine, and then if I replace the left hand side with something with sines, then I'll only have sines in my equation. Okay, if I use the third one, I will still have a sine and a cosine. Okay, so I'm going to use the second equation. We know that the cosine of 2 times x, which is the left hand side, is going to be the same as 1 minus 2 times the sine squared of x. And then we're not going to do anything to the right side. Okay, as soon as you make this substitution, you can see that this is going to be quadratic. Okay, so I need to get everything on one side, make sure one side is 0. I'm going to move things around so that the square term stays positive. So I'm going to add this to both sides, and I'm going to subtract the 1 from both sides. And I'm going to do some rearranging here. I'm going to end up with 2 sine squared x plus the sine of x minus 1 is equal to 0. Okay, so this is something I can now work with. It's quadratic in I only have a sine of x. Okay, one side is already 0, so I can try factoring, or I can use the quadratic formula. I am going to see if factoring will work here. Okay, so I'm going to change this over. I'm going to let u be sine of x. Okay, so this is going to be 2 times u squared plus u minus 1 is equal to 0. Okay, so I'll factor in u and then turn it back into x's. So let's see here. This is going to be 2 times u squared is going to break up into 2u times u. And then the numbers need to multiply to be 1, so that's going to be 1 and 1, but then I need to get the signs to work out. It looks like it's going to be this. Okay, so 2u squared plus 2u minus u gives me the middle term, and then minus 1. Okay, so that's correct. Okay, I'm going to go ahead and replace u with sine of x. And then I need to take each factor, set it to 0, and solve. Okay, so I'm going to take the 2 times the sine of x minus 1, set that equal to 0. Okay, and then I need to take sine of x plus 1, set it to 0. Okay, I'm going to go back to this first equation. it's linear. Okay, so I'm going to isolate the sine x. Okay, so if I add 1 to both sides, I'm going to get 2 sine x is equal to 1, divide by 2. Okay, this is telling me that sine of x is equal to 1/2. Okay, so I need to go to my unit circle and solve this. Okay, so go to my unit circle, and I'm trying to find angles between 0 and 2 pi such that the sine of x is equal to positive 1/2. Okay, so let me make sure that I wrote that down correctly. So yes, okay, so we're going to go back to the unit circle. Okay, the sine value is positive. Okay, we know that the sine value correlates to the y coordinate. Sine is positive in quadrants 1 and 2, so that's where we need to be looking. Okay, so which angles in the top half of the unit circle have a y coordinate of 1/2? Well, right here, so it's going to be pi over 6, and right here, so 5 pi over 6. Those are the two angles that we're looking for. Okay, so pi over 6, 5 pi over 6. So let me go back and jot those guys down. Okay, so we're going to get the solutions to this. I'm running out of room, sorry. Pi over 6 and 5 pi over 6. Okay. All right, so if you want, we can go ahead. These are between 0 and 2 pi, so we can plug them in to the box here. If you want, we can go ahead and form the general solution. Okay, we'll take a solution and add integer multiples of the period. Okay, this had both sine and cosine. Okay, and we solved it through a sine, through using sine. So we should be using 2 pi as the period here. Okay, we'll make a second statement for 5 pi over 6, add integer multiples of the period. Okay, we still need to go and solve the second equation, sine of x plus 1 is equal to 0. Move the 1 over. Okay, we need an angle whose sine is -1. So going back to the unit circle here, now we need to solve sine of x is equal to -1. Okay, so again, sine is associated with the y coordinate. If we look at the unit circle, there's one angle between 0 and 2 pi that has a y coordinate of -1, and that's going to be 3 pi over 2. Okay, so that's going to be our answer here. The x value, which is the angle, is going to be 3 pi over 2. Okay, so let's go write that down. So this guy, the x value here is going to be 3 pi over 2. Okay, that is also between 0 and 2 pi. Okay, and then to generalize that to all solutions, take that particular solution and add integer multiples of the period. We are done.